Yeah. So, but there are. I mean, there are ANIs that are like. Well, I mean, there's some that really are kind of starting to look like things that we might expect that would go into something like an AGI or an ASI.
Yes.
Just little hints of kind of like, oh, maybe things are moving in that direction a little bit.
Yeah.
So the stuff there's been actually, I'm going to go so I'll start with an older example. So okay. I think in like 2005, there was a model of the like neural. It doesn't really have a brain, but like the neurons basically of it's like a worm. It's like a polychaete. It's not a polychaete.
Super simple worm.
Yeah.
Like some kind of nematode worm. Or was it possibly even C. elegans, which is like that model?
Yes,
it's like
it was.
A model organism that's used like extensively in like biomedical research, biotechnology, all that stuff.
So it's got like 302 neurons or something.
Which is mental.
And they
considering that the human brain has something like 100 billion.
Yeah. That's 300. Like, the fact that that's in hundreds.
And that is crazy, actually, just thinking about that. Like an animal that does what it does, like does all worm stuff, like swimming around and looking for food.
Well, exactly.
302 neurons. And
so they built a model of it, and like a
computer
digital model.
Digital model, yeah.
And the inputs and outputs they made are set the same as like the worm sensors. And basically, you would put in the food kind of input, and the behavior of the system the output of it would be the same as the worm would be doing in its like rudimentary sense. So they're not telling it to do this, it just would behave in the way that like a worm would. But again, like in a very rudimentary sense. So it would like react in the same way the worm did to food. It would like do whatever the worm does, but it wouldn't be able to learn things. So it was like it was similar but very different in the same sense. Like the worm would be able to if there's like a higher temperature somewhere, it would be able to learn with just those 302 neurons that higher temperature equates to possibly like a more increased chance of getting food, whereas this like neural network thing doesn't have a clue, wouldn't be able to do that at all. Right. And it does that. It doesn't do that by adding neurons. It does that by like strengthening connections between certain neurons. And this system couldn't do that, but they could model some like extremely basic behaviors, not by predisposing it to doing
just by having that network.
By having the network in the same like structure.
Same structure and the various components of it. Having the same like or similar like thresholds of like firing or whatever so like a signal comes in and it has to have a certain threshold to like then send off another signal, and these because it's only got 302 neurons, because it's so heavily studied, these aspects of it are quite well known, so they're able to actually put that into so this actually goes back quite nicely to that whole brain emulation stuff we were talking about just previously. So this is the same approach that some people want to take to designing an AGI, but instead of using a worm brain with 302 neurons to do it with the human
increasingly advanced
with
brains,
100 billion,
and then 100 billion, and then potentially you take that 100 billion, and you've at that point very well like how you structure intelligence and maybe integrate information or whatever, and you could add things onto that to make it smarter than a human, and then it would probably end up doing its own thing. That might be a way to kind of like allow it to recursively self-improve or something. So that's like that's similar to the approach. The worm's similar to that approach.
Yeah, but it's mental. Like thinking about that, like all you need is that network in place, and it just without any programming, it just does what the worm does on a very basic level. Yeah. Like.
You probably find that if they made that network so it could strengthen connections in certain places and do some of the more advanced stuff, it would essentially just behave as like a worm.
You've just made a worm.
And you sort of, is it a worm? I mean, we'll go into like is it a worm? It's kind of into the consciousness thing, but I mean, maybe you are essentially making an entity.
Rudimentarily, like it has a phi level, surely.
Yeah.
I mean, we are just in this discussion. We're just sort of accepting that integrated information is consciousness.
Yeah, we are.
Well, that's fine.
No, but but even forgetting integrated information, I just mean if you're able to create a program that is behaving exactly the same inputs outputs, learns like more about a temperature or whatever as a worm. It's not a worm because
not a worm, because to be a worm you have to be like
a worm,
an actual worm.
Yeah, there's no like biochemical inputs. No. But you could anyway. That's one way you could like model.
It might think it's a worm though.
Yeah, I don't know. There's probably more. There's more that goes into it than just the neurons, though. Yeah, of course.
Yeah, sure.
Yeah.
But so that's one example of like is that an ANI?
Yeah,
sure.
I think so.
Yeah. Oh, it's possibly a step towards the direction of building some kind of AGI. But
Yeah. So things that are going to contribute to an AGI are going to be like ANI steps that are kind of like not down the traditional kind of just play drafts route. It's going to be like a self-learning kind of like self-evolving thing.
Yeah.
Sorry.
Of course, I mean, if an AGI, giving our early definition, is something that has human level intelligence, then like a worm isn't that.
But you're learning how to build these new like neural networks.
Yeah.
That emulate organisms, and that's a step towards, maybe if you want to go down that route of trying to emulate a human brain, that's a step towards creating an AGI.
Yeah. There's some really impressive self-learning programs as well coming out.
So you'll have seen in the news, like, you think about DeepMind.
DeepMind, yeah.
So Google DeepMind, they bought DeepMind it wasn't that long ago actually, was it 2 or 3 years ago?
Yeah.
And it's a London-based company, I think.
Yes, they are. Yeah.
And they essentially have been building algorithms and AI systems to play games. So things like
Space Invaders is one of the first
Space
ones.
Invaders.
But actually they didn't build it to play Space Invaders.
That's the key thing.
Yeah.
But the idea behind this stuff is to like play games, but play them in a generalized, non-pre-taught way. So like they built an algorithm that could play like 10 different games.
Yeah.
But not from being told the rules of the games. Well, sorry, not from like being pre-told like these are all the different moves, etc., and programmed in how to do that. Rather, the AI would play the game again and again and again, knowing the winning conditions, and would learn how to play that game better and better from losing.
It wouldn't. Yeah,
it would just know the pixel
doesn't even play. Yeah, just knows the pixel positions. Just have a stream of data coming in.
Yeah.
Doesn't even know that it's playing a game.
No.
Just it had some kind of preset. I guess some preset winning conditions, as you said.
Yeah, I think so.
And it just like tries things like, oh, it changes this, and then maybe that does nothing. Maybe it changes this, and then the little ship at the bottom moves like 1 pixel left or something, and it realizes that it survived for slightly longer by doing that. So you got slightly closer to those winning conditions by doing that. So just by through doing permutations of that, eventually it just optimized it, and it was absolutely smashing Space Invaders. How long did it take it to get to that point?
I think they left it
overnight, like 11 hours or something like that.
So they
came in the morning, and it's just like.
They come exactly. So they went to bed, and it was rubbish. It would just like move out the way, and it would miss, and it would just be terrible and never get any scores.
Yeah.
And they came back in the morning, and it's playing it better than any human can.
Yeah, that's nice.
And the same type of the same algorithm, I think, could then be applied to like multiple other games that had like a similar kind of. The game was different, but the inputs and outputs, or the way it was constructed was similar, so they could apply it to these multiple things.
Yeah.
Which is, I mean, it was like discovering new ways to play these games that hadn't been like found out by human, experts in playing these old school video games. New ways to like bounce, in that game where
the ricochet game thing, whatever it's called, where you like bounce the little like.
You bounce a ball off and it smashes blocks at the top.
Yeah.
And it would like find certain ways to do like minimal inputs as well.
Yeah.
It found like the most efficient way to do it.
Yes, it did.
So with minimal inputs, it would just like let it bounce and then just do all this crazy stuff that people didn't expect it to be able
and that
to
a human could possibly not even do, because it requires like a level of precision that only if you have like the raw stream of like data from the game coming in, that you'd be able to actually do.
Yeah.
So that was crazy.
Yeah, it was crazy.
Was it the Go thing theirs as well?
Yeah. So that was more recent.
That's pretty recent actually. It was a couple of months ago.
Yeah.
Right?
So you probably have heard that like AIs have been able to beat people at like chess or whatever. When did the chess thing happen?
80s maybe? Or
80s,
90s?
yeah.
I'm not sure. That was actually thought of as being like a criteria of being human level intelligence at that point. Before that point, it was like that kind of level of like planning and logical thinking and stuff was a domain of humans.
Oh,
I'm talking
really?
about decades ago. Yeah.
I didn't know that.
And then obviously like they just built a computer which just smashes everyone at chess and just calculates all the optimal moves like every time and will beat a human every time.
There's a video of that, like one of the, I think possibly the number one chess player in the world, like just going getting really angry where the computer's just beating him, he just walks off. And this thing's just there like beep 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 beep.
Loving chess, but Go's a whole other kettle of fish. Go's like just really complex Chinese game, isn't it?
Yeah, board game.
Chinese board game, which is like far more complex.
It sort of looks a bit like checkers, sort of. It's like black and
like
white.
Othello. Have you ever played Othello?
I've never heard of it.
Really? It's again, it's like a board game. Like you have like black and white tiles, and you turn them over if they're if you like flank. It's really, I think it's basically a really simple version of Go. Go is like insanely complex.
Oh, maybe I have. Anyway, yeah. Go on.
Has all these like permutations, like billions, right? Billions upon billions.
I think it might be trillions.
Trillions of permutations.
Yes,
of, like,
it's like 10 to the some number. It's ridiculous.
Yeah, and up until now, no AI has ever been able to beat like the top human players at Go.
No, because there's just too many variables to build.
Yes.
Until now.
Yeah, until now. Thanks to DeepMind.
Yeah, so they built using these like self-learning algorithms. This
same kind of stuff.
Same thing as the video games, just playing itself at this thing over and over again, and it learned how to play Go to a level, which is able to beat some top Go players. I think it was 5-0. Like won 5 games.
Nice.
Apparently, the guy against one of the like top Go players, or like a professional Go player.
Yeah.
And he said that the way it was doing it's kind of the way it was playing was like he felt like he was playing a human.
Was it
because of the way it was kind of like using like predicting things and kind of
right.
Just
like
the way
doing
it was
dummy
reacting.
moves and kind of like setting things up. And yeah, man,
which is crazy.
That's crazy.
And they're set up to play on like between like the 9th of March this month.
Yeah.
And the like 12th of March or something like that. So like 3 or 4 days in some place. Might be in Hong Kong or something like that. They're going to have the I think it's called AlphaGo, the program. This like algorithm they've written to do it is going to be playing the top Go player in the world. Over like a cloud server.
Oh really?
Yeah. And yeah, they're going to see if they can beat the top Go player in the world with this self-learning thing. I imagine it's probably going to win.
Yeah. I want to watch that. Well, actually, I have no idea.
I think they might stream it.
Yeah.
But it's over like 3 days.
Yeah.
But
I
want to watch the first game just because I mean I don't know how long a game of Go takes. It might take hours.
I just want to see this guy like the Go champion just being like just not believing. Like what the hell's going on with this thing? Yeah.
But that's. Yeah, so it's again it's this self-learning, very very new kind of type of system they're using. I mean, whatever it does, is far more advanced. They keep getting like publications in Nature and things. This is a big deal. This DeepMind.
Yes, they are. I mean, they've been heavily invested in by like some big names. I mean, Google bought them. But other people like Elon Musk has donated loads of money to them and stuff like that.
They want to keep an eye on AI development.
Yeah, which is fair enough.
Yeah, I mean, Jesus.
Yeah.
And Christ knows what they were going to end up. Well, I mean, if we think about like how you might go from ANI to AGI, kind of like, I mean, there's a possibility that you might not even realise that happens.
Yeah,
and that's why people are scared.
That's the thing. I mean, we've been talking all the way through this about people sort of pursuing AGI as like a goal, like right, let's design something that's generally intelligent. But it's actually quite possible with some of these really really complex. Narrow intelligence systems that already exist, that they become sort of more interdependent on each other, and this all just kind of happens like naturally as things get more advanced, and we kind of rely on them a bit more, and we program in more capabilities into them and more learning capabilities. That you get something that might be thought of as an AGI emerging without us aiming for it, like without us even possibly realizing that it's happening. I
mean, maybe. I mean, it's possible, right? I mean. Something like a self-learning algorithm that has to learn how to do something. I don't know. Would you not realise though? Maybe.
I mean, maybe not realising is the wrong way of putting it. But
you don't quite you realise that it's able to do some sort of like self-improvement kind of systems, but you don't realise that it's becoming. It's going through like a runaway phase. You don't realise until it's too late and it's gone through it.
Yeah, like so the Google image search. Thing, which is basically just, I think actually not the image search where you upload an image and it just like looks at the similar image, because that's obviously quite a narrow intelligence thing. But this thing that they've been coding in, which is the point of it. I think the express point of it is that because it's so difficult for a machine to recognize an object.
Yes.
Basically, if you give a machine like a picture of like a glass or something, it will just query that against like a huge database of like similar images until it finds like a close enough match or an averaged match, and then those images are all assigned like a name like glass, and it's like, okay, that must be a glass, just process of matching. Sure. But our brains don't do that. Our brains, like we were talking about the other week with that idea of like the apple, picture of an apple versus an actual apple, like the conscious experience of seeing an apple, you're integrating all these different parts of like your knowledge of what the actual meaning of an apple is.
Yes. Like
more than just like the raw like image data coming into your eyes. There's more to it than that. So the Google approach, which on a very basic sense is trying to get at that, is like trying to teach through self-learning, trying to teach like this system how to extract like at least a word out of an image. So like you give it an image, and it's like it recognizes that as like a glass or an arm or a tree or whatever, in like all these images in all these different situations.
But they had like one where they're like asking it to recognize like a dumbbell, and like it ends up having these different images of dumbbells, but they always have an arm attached to them.
No, well that's the thing. So the actual thing was designed specifically to you give it an image, and it extracts a word from the image.
Yes.
Right. Whereas what's been applied to the other way around is you feed it a word, and then it generates an image.
Yeah, in this particular.
And those images are nuts if you look them up. Like the dumbbell ones is this weird sort of like distorted kind of like, it doesn't look quite right.
No.
But yeah, it's been
like
put in like
shadowed kind of by lots of edges of other dumbbells, and kind of like this weird kind of kaleidoscopic kind of image generated from all these different like neural networks, which are feeding in like different answers to different levels. So it goes through like 10 or 30 like different like levels of neural networks, right?
Yeah.
In which they like confirm or kind of it basically like rudimentary like integrated information, asking different things about different types of like why this might be something or why not. And it gets to a point where it generates kind of these when you feed in these words, it will generate like this kaleidoscopic image of what it thinks a dog looks like, or dumbbells, or and they look like someone on acid has tried to paint something.
It's crazy. Like just look it up. I mean, you can Google something like Google image dreams or something like that, and you'll find it, and it's just like some of these pictures are just absolutely like you can't quite make. You look at them and you see exactly what it's meant to be, but you also see like 10 or 30 other things in there just kind of weirdly like weird layered on top of each other. Yeah, it's really strange.
And like a car with like a sort of dog head and all these like really bizarre
like a tree
things.
A tree that's like got the heads of dogs like kind of coming out of it, and it's fucking strange
it's
stuff.
Really odd.
But that's essentially what it's doing is try in a very rudimentary way is it's trying to extract meaning from a word. So you give it a word, and that's its interpretation. It's like mental image of that word. So when in the same way that you can say the word like apple to somebody and they know what an apple is, this is like, they know what an apple looks like. This is that system's sort of version of that in a very, very basic sense. And to do that, it's obviously drawing on like the internet, images on the internet. Huge, like an almost infinite database to draw on of experience, of knowledge, of experience of what like dumbbells look like or trees look like or whatever. So I mean, the internet itself, just the fact that you can put something like a system like that, an algorithm like that, give it the internet to work with, and it can come back with things like that. The internet's like it's just ripe. It's like a breeding ground for these kind of artificial intelligences.